Hello wonderful person, this is Anton, and today we're going to discuss a somewhat intriguing discovery from a galaxy really far away. But in this case, once again, a mysterious discovery that even after a few years, still does not really make a lot of sense. But specifically, we're going to be discussing something that was actually found inside a gravitational lens. But not this one, and instead it was actually found right here. Here we have an almost perfectly circular gravitational lens, referred to as JVAS B1938 plus 666. A relatively big name, but an even bigger mystery, because here, inside this almost perfect Einstein ring, scientists discovered this object that they now refer to as a mysterious perturber. A tiny, previously invisible object that was actually hiding inside this ring until someone noticed it just a few years ago and then analyzed it, revealing that it was actually something super strange. And so even though in this image this object appears super tiny, it's actually currently reshaping the very foundation of modern physics, redefining the basis of our understanding of how we think universe evolves and how things like dark matter seems to interact with matter around it. But to understand why this particular object is important, we first have to look at the setup and exactly what this image is showing us, because otherwise it will not make sense. And so basically first we have to actually understand what this lens is showing us. And well, if we see this from the side, we're going to be seeing two major objects. First, 6.5 billion light years away, there is a massive elliptical galaxy. That's actually the galaxy that's forming the lens, and it's the mass from this galaxy that's distorting the light. But behind it is another object approximately 17.5 billion light years away from us, and this is of course the source galaxy. That's essentially the light that forms this perfectly circular lens, and that's what we're seeing in many of these images from previous studies. And the reason this is even possible is because these two objects are perfectly aligned with planet Earth. And so the closer galaxy acts as a kind of a cosmic magnifying glass, bending the distant light into a glowing ring. Naturally, this is something we've seen many times before, and we've even talked about some of the more recent discoveries in one of the videos in the description. But in this particular case, there is a bit of a catch. And so when astronomers look at this ring, they see these tiny wiggles or perturbations in the light. And in this case, these ripples are usually caused by additional small masses. It's a little bit difficult to see them in this image, but they do become a little bit more obvious when analyzing the entire object with higher resolution observations. And these additional wiggles have obviously been seen before, mostly because a typical massive galaxy will also contain additional masses orbiting around it, such as for example various dwarf galaxies, or even the mysterious halos of dark matter. But in many cases they are too small to see directly, and so we can only see gravitational effects inside the lens itself. And well, for a very long time, for several years actually, researchers believed that in this particular lens there was one major perturber. This is actually something you see here, and it seemed to be some kind of a satellite galaxy, approximately 190 million times the mass of the Sun. By itself, this would not be unusual, until a more recent reanalysis that actually did discover something somewhat bizarre. In this case, this was actually a reanalysis by researchers from Harvard, with this reanalysis focusing on the redshift, which for many galactic objects that are visible, allows us to determine the distance. And the reanalysis of the distance determined that this object is not orbiting the main galaxy at all. As a matter of fact, it's not part of that main lens, and seems to be in this location completely by accident. So basically it's a kind of a line-of-sight perturber. Basically imagine some kind of a galactic object, or really any object, passing between Earth and that distant galaxy, somewhere along this line. But here the strangest discovery was the fact that this object seemed to be located behind the main lens, and was thus a lot more massive, with the reanalysis eventually discovering that this was at least 10 times more massive, and was way behind the original lens, so somewhere right here. And so in that particular study, researchers essentially concluded that we had to be really careful assuming that we're looking at some kind of a dwarf galaxy or satellite galaxy, because sometimes these bizarre interlopers can actually be individual objects and can also be somewhat mysterious themselves. But the thing is, this was not even the real mystery. The real mystery came later, because first in early 2025 and now in 2026, researchers discovered something else super strange, a kind of a disruptor object that seems to be in orbit around this particular galaxy. Or just to rephrase this particular galaxy that was passing behind the lens seemed to contain something in its orbit which is now creating a lot of buzz. Because here we have no idea what's orbiting it, but it's something that contains at least 1 million solar masses. And based on previous studies, researchers determined that it cannot be just some kind of a black hole. And this was actually exciting for so many different reasons. First, this was the most distant object ever detected through a gravitational lens. So this was the farthest object ever discovered through gravitational lensing. But it was also very, very strange. And the strangest in this case was caused by its gravitational profile. Or to be more exact, its density profile, when scientists tried to discover where most of the mass was located and how it was distributed around the central point. Because the only way this object is even possible is if it contains a structure we've never seen before anywhere. It does not seem to be a regular galaxy, and also does not seem to be any kind of a black hole. Okay, I think I need to clarify this. So usually when we look at galaxies, most galaxies appear kind of cuspy. It's an astronomical term that usually refers to how density is distributed from the center to the outskirts. If you were to visualize this, it would look something like this. As you get closer and closer toward the center, there's a kind of a mountain peak as density increases dramatically. Now this doesn't apply to all galaxies, but that's generally what's expected. And so for a typical galaxy, we expect a lot more density in the center, and then a kind of a curvy distribution as you move away from the center. But this bizarre shape, Perturber shape, does not seem to fit this description. It actually has two separate parts. First, it has a central point mass, which makes up about 25% of all of the mass. In this case, astronomers believe it might be some kind of a central black hole, or possibly some kind of an incredibly dense core of stars. But then, as you move away from the center, the density suddenly flattens out and forms a kind of a large disc-like shape. And so instead of having a mountain peak and a curve, we basically get a flat shape that researchers sometimes refer to as a core instead of a cusp. Okay, well, I guess here the question might be, why does this matter? Why does the shape of a dark blob 17 billion light years away from us matter at all? Well, naturally because this does not fit any models, and also because it currently contradicts the ideas behind dark matter itself, specifically cold dark matter. We're talking about 84% of all matter in the universe that we still don't really understand. And that's of course the idea that's supposed to explain why galaxies don't fall apart, and why galaxies form shapes that we generally see everywhere. And so in the standard model, also known as lambda CDM model, CDM stands for cold dark matter, the prediction is that a lot of these dark blobs should be somewhat cuspy and generally not have this flat core. But that's precisely what's seen inside this object. And so if this object does contain dark matter, and if it has a flat core, it basically suggests that we might be wrong about dark matter particles, and especially about them being cold, or essentially containing almost no energy. Instead, this seems to confirm the idea referred to as self-interacting dark matter, which may suggest that they're bumping into each other and are actually producing different types of shapes. And so in that particular model, if dark matter particles can collide and can interact with each other, eventually spreading out energy and creating various galactic shapes, they can eventually start forming a disc-like shape, kind of similar to an accretion disk. And if these collisions are frequent enough, they can even collapse into a central black hole, which surprisingly seems to match this perturber almost perfectly. Or I guess just to rephrase this, the only way that scientists can even explain this particular shape is if dark matter is not the particle we thought it was. Basically, it has to be some kind of other particle that seems to be able to form shapes that we never thought were possible. But this is of course assuming that this contains a lot of this dark matter, which is why some studies try to discover what else we can find here, because maybe this can all be explained in some other way. And specifically, a lot of studies focus on trying to find stars. So for example, if the James Webb Space Telescope can actually see stars here, maybe this can be solved in an entirely different way without requiring any additional models or any additional explanations. But so far, previous observations and observations using Hubble discovered nothing. And so right now this seems to contain no light. And if it does not contain stars, it means that this is not some kind of a weird dwarf galaxy, it really is some kind of a pure dark object that seems to violate current laws of physics. Now the James Webb Space Telescope has not observed this object yet, but the observations are planned and it's going to happen sometimes in the next few months. As a matter of fact, here's the proposal for this, which means that we might get some data really soon. But as of early 2026, right now this is a really big mystery, and also a mystery that represents one of the perfect locations to test ideas behind gravity. Mostly because the gravitational observations in this case are extremely accurate, with this perturber object allowing us to test various gravitational models to see which one matches the observations. And so even though initially scientists thought that this was some kind of a dark galaxy, Instead, this seems to be a really massive object whose true nature is currently unknown. But it does seem to resemble some kind of a massive black hole surrounded by a flat disk containing 750,000 solar masses. And at the moment, the standard model cannot explain what this is. Since we're not seeing stars, it does not seem to be a star-forming galaxy, and instead seems to represent something entirely different and currently unexplainable. And especially because this object is not even that big, just under 500 light-years across. And so the question here remains, is this some kind of a galaxy? Is this a bizarre black hole surrounded by something really strange? Or is this just a chunk of dark matter with a bizarre shape formed by interacting dark matter particles? Now we know these dark matter halos and these dark matter chunks seem to exist everywhere. As a matter of fact, one of the recent discoveries from the Milky Way that you can learn about in the description does find evidence of one of these objects right here, not so far away from us. That one was actually 2.5 million solar masses, so just a little bit bigger, but it potentially represents something extremely similar, and something that one day might help us solve the mystery of dark matter once and for all. For now though, we still have no idea what this is, and we're going to be learning more about this once there are some additional observations. Until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else, support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.